SwayamPrabha. Digital India. Educated India.
I welcome you all to the session of thermal engineering, and today we shall discuss about this cycle, that is reheat cycle. In fact, we have discussed about this cycle in the last class, and in continuation of that discussion, today we shall go for the analysis and little more of this particular cycle. So, if you try to recall, we have discussed about the Rankine cycle as well as several modifications of the Rankine cycle. So, if we try to write again what are those modifications? Modifications are, so modifications of ideal Rankine cycle. One is lowering the condenser pressure, number 2 is increasing the boiler pressure, and number 3 is superheating the steam beyond a particular point, that is beyond point 3. So, all these 3 modifications we have discussed essentially to have higher thermal efficiency. Nevertheless, we have also discussed about the demerits of every such modification in the context of the smooth and travel free operation of the plant, as well as the obligation of having higher thermal efficiency. What are those? We have seen that perhaps by lowering the condenser pressure we can achieve higher thermal efficiency, but doing this we are going to invite another problem, that is the quality of steam at the exit of the turbine becomes very poor. So, it is not acceptable. Not only that, in addition to the quality of steam at the exit of the turbine, most importantly we cannot really reduce the condenser pressure drastically, because mostly condensers are operated at a pressure which is below atmospheric pressure. So, if we reduce more, then perhaps leakage of air from the surroundings into the condenser will be there, and this air which is getting leaked into the condenser will create a resistance for an efficient heat transfer between the flowing streams, that is steam and water. So, this is not suitable. If we look at the second one, that is increasing boiler pressure, we have seen that if we somehow can design a boiler to operate at a higher pressure, perhaps we can increase the efficiency, but again we need to compromise the quality of the steam at the exit. Last one, superheating the steam, we also by adopting this particular modification we can increase the efficiency as well as the quality of the steam at the exit of the turbine becomes high. It is not very poor. So, it is quite I can say important to go with this particular modification, but we have discussed that we cannot superheat steam beyond a particular limit, because that is restricted by the metallurgical consideration of the blade. So, if we rule out this particular, that this is not feasible way, even if we go for the second and third one, we have seen that these options are not the viable option for the enhancement of the thermal efficiency of the power plant. So, why not? Idea is, why not to look into the combination of these two. So, if we can increase the boiler pressure, that means if we allow the plant to operate, rather if we allow boiler to operate at a higher pressure, together with if we go for superheating the steam, perhaps the problem associated with the reduction in the quality of steam at the turbine exit can be increased by if we superheat the steam, and at the same time if we operate the boiler at a higher pressure, we can achieve higher thermal efficiency. So, idea is to combine these two options and to have a particular cycle. So, to this end, reheat cycle aims at attaining a high thermal efficiency by making use of the high boiler pressure as well as superheating the steam, but at the same time eliminating the expected probability of reduction of the steam quality at the exit, but operating the plant at a temperature which will allow us not to go for any problem of the turbine blade cracking etc. So, this is what is reheat cycle. So, if we write reheat cycle, so these cycles aims at attaining higher thermal efficiency by utilizing higher boiler pressure and superheating the steam. So, this is all about the reheat cycle. So, basically that we are going from the Carnot one to the Rankine, simple Rankine cycle, ideal Rankine cycle. We have identifying several issues involved with the simple Rankine cycle. We have looked at the modifications, and then having discussed about each and every modification, we have critically discussed about the disadvantageous feature. Now, we have found that perhaps the first one is not a viable option at all, even second and third one, these two options are not also viable options, but we can use the combination of these two essentially to have high thermal efficiency, but eliminating the problem associated with poor quality of steam at the exit, as well as we can operate the turbine at a high temperature without having any problem related to thermal crack generation inside the blade, in the blade. So, this is essentially the reheat cycle. So, now if we go to the next slide and if we discuss about little bit of this particular cycle. So, that is reheat cycle. So, idea is we will be designing a plant in which boiler will operate at a high pressure, also need to go for superheating the steam. By how it is accomplished, this to accomplish this, what is done, steam is allowed to expand in two stages. So, there are two different turbines, one is high pressure turbine and another one is the low pressure turbine. In high pressure turbine, steam will be allowed to expand isentropically at the exit of the high pressure turbine, steam will be taken for reheating through a separate coil in the boiler, and that reheating will be done at an intermediate pressure, and after reheating, that reheat temperature would be approximately to the same temperature as it was done before entering into the turbine, I mean the high pressure turbine, and this reheat steam will be again allowed to go into the low pressure turbine, wherein again steam will expand isentropically to the condenser pressure. So, let us briefly draw, let us draw the schematic diagram of such a cycle, and then we shall discuss. So, if we draw over here, so this is the boiler, so this so this is condenser, and so this is low pressure turbine, this is high pressure turbine, and from the condenser again so this is what is the concept. And so this is what is the concept. Let us identify the state. This is 2, this is 3, 4, 5, then 6. So, you can see, let me write here, this is high pressure turbine, and this one is low pressure turbine. Okay. So, you know that this is the concept. What is this is different than what we have the cycles we have discussed so far till now. So, this schematic is different in one aspect, that is here the steam from the boiler will be taken into the high pressure turbine, steam will expand isentropically, at the exit from the high pressure stage turbine will be, that steam will be directed to a heating coil that is placed in the boiler, and while steam is passing through the boiler, passing through this heating coil which is placed inside the boiler, it will be reheated again, and that reheated steam will be taken to the low pressure stage turbine, wherein again the steam will expand isentropically, and it will be allowed to expand up to the condenser pressure, and the remaining part is as usual. So, basically we can see that the condenser that condensate will be collected and again pumped back to the boiler. So, this is basically so this is the place where we will be having a Q out. So, I shall write in, so I will erase it and I will write this is Q out, this is Q in and this is W in. So, again I am telling idea is steam will expand isentropically in the first stage, that is high pressure turbine. So, steam will expand isentropically in high pressure stage turbine, and this expansion will continue at an intermediate pressure. So, you can understand steam is getting expanded. So, this as steam is expanded in the high pressure stage turbine, this expansion process will continue at an intermediate pressure. So, steam will expand isentropically in high pressure stage turbine up to an intermediate pressure. So, this is not the condenser pressure, right. Then the steam will be taken after expansion in the HPT in high pressure stage turbine, steam will be routed to the reheating coil placed inside the boiler. So, this is the coil. Okay. So, this is and while steam is taken to this reheating coil. So, let me write here. So, this is reheat coil, okay. And then this steam after heating. So, this heating is continued approximately equal to the same temperature at it was having at state point 3. So, this is very important, steam is, let me write. So, steam is reheated approximately equal to the original superheat temperature. Okay. Finally, the reheated steam is allowed to expand isentropically in the low pressure stage turbine, and this process continues up to the condenser pressure. Okay. So, this is all about the processes, and you can understand the remaining processes are as usual. So, we have seen. So, up to the condenser pressure, so again it will come to the condenser exchanging heat with the coolant which will be circulated into the condenser, that collected condensate will be pumped back to the boiler. So, this is the usual process we have discussed. So, if we now draw the TS diagram, which is very important. So, if we draw the TS diagram, right. So, if we draw the TS diagram, which is very important. So, if we draw the process, so this is the condenser pressure, P condenser. If we go back to the previous slide, so you know that this is the state point 1, wherein the thermodynamic state of the working substance is saturated liquid. So, this is 1 and this is pumped to the boiler. So, objective is the pressure will increase and the boiler is operating at a high pressure, because that is what our objective was, to combine these two modifications, so that we can have high thermal efficiency without having the reduction in the quality of the steam at the exit of the turbine. So, now say this is the boiler pressure. So, this is 0.2 and this is the boiler pressure. So, this is 0.3. Now, we are using this too. So, we are allowing the boiler to operate at a high pressure as well as superheating the steam beyond 0.3. Superheating the steam beyond 0.3, that means we are superheating steam beyond 0.3, then steam is going into the high pressure stage turbine and it does work. So, these two turbines are connected to a common shaft. So, while doing work, while expanding in the high pressure stage turbine, it does work on the rotating part of the machine, and steam after doing work, it is taken to this reheating coil. So, this expansion in the high pressure stage turbine takes place up to an intermediate pressure. So, this expansion, say this is an intermediate pressure. If I erase it and if I use another color to represent it, say this is an intermediate pressure. And this steam is reheated in this coil, what I have written, approximately equal to the original superheat temperature. So, it is reheated up to this approximately equal. So, if I give a line over here, so this is the reheating temperature. So, this is basically 4, this is, so this is 4, this point is 4, this point is 5, and then steam is allowed to expand steam is allowed to expand. So, intermediate pressure and steam is allowed to so this is 6. So, now I will erase this part, that will help you to understand. So, if I erase it, so this is the case, just I am connecting like this. So, question is, so we are utilizing high boiler pressure, superheating the steam, but what we are doing? We are doing this, rather to accomplish this, we are now using two different stage turbine. What is important to note, that you know that if we are allowing steam to expand in the high pressure stage turbine isentropically up to the condenser pressure, in that case the quality of the steam will be, so this is 6 prime. So, this is x 6 and this is so this is x 6 prime. So, you can understand quality of steam is getting rather becoming higher if we reheat steam. Also we can have higher thermal efficiency, because you can understand W net is getting increased. So, you know this is the extra amount of work W net we are getting because of this reheating. So, this is delta W net. So, if we allow steam to expand in the high pressure stage turbine up to the condenser pressure, quality of the steam will be x 6 prime. So, x 6 prime is definitely less than x 6. So, basically what we can see, we can increase the quality of the steam at the exit of the low pressure stage turbine. Not only that, we also can increase the efficiency, that is delta W net is getting increased, that is clearly visible from the stage diagram. So, this is the practice what is commonly followed in the modern steam power plant. Now, we can see we have drawn only one reheating stage. It is also possible to have multiple reheating stage. If we can have multiple such stages, then perhaps efficiency can be increased even better. So, for a given or single reheat stage, efficiency increases by 4 to 5%. So, if we by having only single reheat stage, we can increase efficiency by 4 to 5%. Now, why, if we try to look at, if we try to analyze why it is so. So, you know that by reheating the steam, we are essentially increasing the average temperature at which heat is added in the cycle. So, if we try to go back to the previous classes, thermal efficiency will increase if we increase the average temperature at which it is added to the higher temperature part of the cycle. So, by reheating the steam, it is because of such a complex arrangement, we are increasing the average temperature at which it is added to the cycle, and due to this we can have this amount of increase in thermal efficiency. So, by having a single reheat, we can increase efficiency by 4 to 5%. But now you may ask me a question, why can't we go for multiple reheating stage? It is recommended that we can go for multiple reheat stage, but 2 to 3 reheat stages are recommended. Why? See, if we again draw the TS diagram, so if we write it, you can see, so if we have such a multiple reheating stage, essentially, so this is the T average reheat, right. So, if we increase multiple reheat stages, average temperature at which heat is added to the cycle will increase and the efficiency will increase. But why then it is true that 2 to 3 reheat stages are recommended. Why this recommendation is there? Because if we go or if we keep on increasing the number of reheat stages, then you know, if we look at this particular schematic, you can understand that for only one reheat stage, so many arrangements are needed. So, if we keep on increasing such reheat stages, then additional cost involved with the mechanical component, also their maintenance will not be justified by the increment in efficiency. So, let me tell you, we can go for multiple reheating stages, average temperature at which heat is added will be increased, efficiency will increase, but 2 to 3 reheat stages are recommended. Why? Because the additional cost involved with the inclusion of one reheat stage will not be justified by the increase in efficiency that would be obtained. So, that is why it is seen that 2 to 3 reheat stages are recommended, considering the cost involved with the additional arrangement as well as the efficiency that we will be getting out of this. So, this is case. Now, so this is basically very important. What you can understand is that if we go back to the previous slide, so this is high boiler pressure, just try to understand. So, this is we have discussed that we are going to combine these two modifications, increasing high boiler pressure and superheating steam. So, if we now look at this particular TS diagram. So, basically that this is the high boiler pressure. So, say this is 3 prime and this is 6 double prime. So, if I write now 1, 2, 3 prime, 6 double prime, that is high boiler pressure. Now, 1, 2, 3 prime, 3, 6 prime, that is high boiler pressure with reheating. So, we are going to utilize high boiler plus pressure as well as reheating. Even if we are going for another reheat stage, we are going to increase the average temperature. That means, we are increasing high boiler pressure to achieve the high thermal efficiency, but if we do not superheat the steam, then quality of the steam will be reduced. So, x 6 double prime is even less than x 6 prime. So, to increase the quality of the steam at the exit of the turbine, we need to go for superheating. So, idea is to combine these two modifications, and that is what the reheat cycle is. So, you know that we have discussed about the operational aspects of this particular reheat cycle. We have also discussed about critical issues. So, we have also discussed about beyond 2 to 3 reheat stages. I mean it is not economically, it is not advisable to go for more than 2 to 3 reheat stages. But one important advantage is that that we are having same mass flow rate of steam. For the given mass flow rate of steam, we can increase the efficiency. So, that means we are getting higher work output. So, that net amount of work output is becoming higher for a given mass flow rate of steam. So, it is this signifying that specific steam consumption will be low and the plant will be smaller. So, basically if the plant is smaller, the initial cost would be less. So, for a given mass flow rate of steam, we are increasing the efficiency by increasing this W net, delta W net. So, that signifying the low SSC. That means, for a given work output, it requires less mass flow rate of the steam. Now, having discussed about this particular reheat cycle, I would say that if it is possible, that taking steam from the high pressure stress turbine, also the steam which is coming out from the high pressure stress turbine is having huge enthalpy. So, we need to make we should make sure that while steam is again taken to the boiler, enthalpy should not be lost. So, again it would be reheated in the boiler in this reheating coil and it will be taken back to the low pressure stress turbine. So, mechanical cost is involved. Instead of going this particular arrangement, if it is possible to have a certain I mean a particular or special blade material which can withstand the same amount of temperature, then perhaps it is not advisable to go with this reheat cycle. So, the idea is if the turbine blade material can withstand high temperature, then there is no need of reheating the cycle. So, this is what I wanted to discuss today. With this I stop here today and we shall continue our discussion in the next class with another cycle. Thank you.